Good morning, TikTok world. My name is Jerry, coming to you from San Antonio, Texas. It's been a while. Um, I was going to talk to something about, when you talk about the sickle cell trait, sickle cell full blown. Again, my name is Jerry, background biological sciences, and a lot of times people don't connect the dots and look at the advantages. I did a research paper when I was doing my master's program about the advantages of certain diseases. Um, and I feel that a lot of times people don't really put two and two together. Um, anyway, so the advantages biologically, like say you take sickle cell anemia. Um, Sickle cell anemia, full blown, of course, causes health effects in the human person. It causes the formation of the red blood cells to deform. Um, and if you look at different parts of the world and regions, um, like say Ghana, Nigeria, India, stuff like that, you also got to think about what's going on in those regions that are more so, uh, you're going to be more exposed to something as opposed to, say, in the United States, and why the body evolved, why the mutation happened as far as full blown sickle cell, the sickle cell anemia trait, and not having sickle cell anemia trait or the mutation at all. And usually, if you connect the dots, you're looking at malaria. Well, if you get mild to severe malaria from, say, I don't know, mosquitoes, or how it's getting passed on through mosquito and through the blood, you have higher probability that is getting transferred um, that way. Now, if you get severe malaria and you're left untreated and your blood, normal blood, and you get severe malaria and you're not treated within 24, 48 hours, uh, you can die pretty much. And if you, most certain death if you're not, for depending on the level of malaria. Um, but the advantage of the human body through the hemoglobin mutation and the evolution in the gene, um, basically the hemoglobin, like if you get sickle cell trait, you know, uh, you got hemoglobin mutation, which evolution in that gene that makes the hemoglobin oxygen carrying protein in the red blood cell. Um, it keeps, like, say, if you have normal red blood cell, take for instance, normal red blood cell, they're perfectly round, and the hemoglobin keeps the red blood cell round. Well, when you get sickle cell trait, or you get sickle cell, full blown sickle cell anemia, your red blood cells are not perfectly round. You don't have the hemoglobin that keeps that round. And they become curved and can clog the vessels. Now, if you have the trait, not the full disease of sickle cell anemia, you have partial protection, right? So you're partially protected against full or severe malaria from the parasite Plasmodium falciparum. I probably said it wrong or whatever. So Plasmodium falciparum, and so when you have, you know, like say you have uh, regular red blood cells, right? Um, you have a lot of oxygen in those red blood cells, Therefore, that parasite can get transferred. It goes through the body faster. It has what it needs. It attacks the red blood cells, and the red blood cells carry, and they got oxygen, and it just explodes. It just keeps going. It can has a great motel. You know, when you have the sickle cell trait, or you have a the full blown anemia, your motel, the walls are falling, the top of the roof is falling. It doesn't have a great environment. It basically it is disrupting the malaria from transporting and growing within, say, the motel. It can't just flourish and stay forever and replicate and do all this other stuff. So what happens is, if you have the sickle cell trait, which is the benefit, is the trait, um, the body recognizes the damage in the cells, and it can remove it faster um, through the spleen because it recognizes it. The red blood cells that are kind of deformed, not full round and all that, they get removed faster through the spleen, and therefore you have protection. Um, the parasite has a harder time reproducing in the altered cells because they're not fully oxygenated and they're fully round. So, from the lower oxygen inside the cells, it creates a hostile environment for that parasite to flourish. And it interrupts that environment. And usually, again, malaria, you got to think about like where you live in the world and why the human body does what it does, how it evolves and how it mutates, and why there's higher levels. And some people think, okay, if I have sickle cell anemia, which is, it's a, it's the disease is not, you know, um, a great disease. It does affects oxygenation in the body and all that. Now, if you got the trait, which is good, you actually have a middle ground protection. Now, it depends on the different parts of the world. Now, say, usually you have higher levels of sickle cell trait and you have higher levels of sickle cell anemia in different parts of the world. You got to think about how the body mutated, where it was at, and why. A lot of times, a lot of people don't ask why. They don't ask where. They don't really look at what's going on. There might be different levels of carriers like mosquitoes and treatments and medical. Um, so when you look at all this, in the United States, we might go sickle cell trait, or the sickle cell full blown sickle cell anemia is the worst thing in the world because it's a disease. It shortens the lifespan if you don't get treatment and you don't, um, antibiotics or certain levels of things that can make your life easier. But the majority of the sickle cell traits and how the body evolved, um, and it was due to like malaria, a parasite. So the body, was adjusting itself. Um, it mutated, and that is evolution. And through evolution, creates protection. Um, so you can, what's the trade off? Well, if you get mild malaria and you have regular red blood cells and you don't get treated within, a certain amount of time, you could die within weeks. If you have the trait of sickle cell anemia and you get a mild case or even a severe case of uh, malaria, you often have higher probability of survival. If you have full blown sickle cell anemia, which you already have in difficult time with that disease, right? You have a higher level, because the strain on the organs and the strain on the red blood cells, not fully round, it is full blown. You're already having a difficult time, and then you get malaria on top of that. Well, survival probability if left untreated, you know, you could have difficulties and pass. You know, now when you're looking at all three, or you look at the normal lifespans of sickle cell, a normal person, United States, Nigeria, stuff like that. If you look at a normal lifespan, just say you're up to men and women have different lifespans. Women usually live a little bit longer, depending on lifestyles, of course, take into account. Um, say up to 81 so years. When you have sickle cell trait, and if you manage it and stuff like that with things that can make your life a little bit easier, you can be in your 70s or longer, depending on lifestyle and conditions. And if you have full blown sickle cell, of course, your lifespan may not be as long, but you're still 65 plus. Now, go into the regions of the world that, and we're just looking at generalistic, we don't have the whole paper written out, and specifics and statistical analysis and all that side by side, and I don't have it in front of me and broken down for you. But if you have, of course, depending on the parts of the world, uh, you know, if you get malaria, it's pretty much like certain death. Like depending on the extreme, how extreme it is. So, you know, what do you want? Do you want to die within a few days, a few weeks, or do you want the advantage of the mutation, so you can at least live 30? Before certain parts of the world, you could die in your 20s. If you had the trait, you would at least live through your 20s and at least have offspring and at least have the advantage from the trait to have offspring, at least to carry on and evolve and have evolution, for family. Now we are getting better around the globe, and there are better medical treatments and stuff, but they're still lacking. We don't have everything in the globe just perfect and stuff. The United States, we usually have medical treatments and facilities. We usually have access to more things as opposed to, like, say, second or third world countries. So when you look at things, um, you know, and you're looking at life, uh, having the sickle cell trait, you have it gives you a opportunity to live at least, uh, before, um, in your 20s, 30s. Now, since things are evolving and you have access to more things and better treatments, you have the advantage of being able to go into your 60s, possible 70s. Um, and so, case in point, conclusion, you know, basically, if you have red blood cells that have, it's lacking the hemoglobin for the oxygen carrying protein, or the oxygen carrying protein, red blood cell hemoglobin, which keeps it round. you know when that parasite is trying to flourish, it's disrupting the environment. So all things as far as the sickle cell trait is not always negative. It just means that the body had mutated, um, or had it where it made it more difficult for the malaria, because malaria is, even with people that don't have any traits or have the full blown sickle cell, you, depending on the severity of it, is almost certain death if you're not treated for malaria, with brain swelling and stuff like that. And if you had or have the sickle cell trait, it is a protective mechanism, like the body had adapted in order to carry on life and to carry on offspring. you know so a lot of people don't connect those dots, but I just thought, you know if people are living their life thinking, okay, well, I got the trait, or I've got sickle cell anemia, and it depends on where you are in the world. I hope this helps clarify. You can live a full life if you have sickle cell trait, um, and or if you have sickle cell anemia. Of course, that's more of a strain on the body, but you can have some treatments um, for the disease. Um, but again, you have to look at what and why the body has sickle cell trait or sickle cell anemia, and what it does, and why it evolved into having, why it's like a protective mechanism. Um, Now, the people that have full blown sickle cell anemia, of course, you still need to be, treated, um, and there are things to make your lifestyle or your life beneficial, and where you still can, because there is medical treatment. But again, the trait of it is the body adapting through evolution to combat malaria. It helps combat the parasite, and it disrupts the environment so it doesn't flourish due to those regions at that time and the exposure, um, from evolution. You know, Again, I did a paper on this probably about 15, 20 years ago, um, and you know, college and what have you. But it's not all bad of what people think. So I hope this helps someone. Maybe to brighten their day up a little bit if they have the trait and they think, "Oh, my life." No, no, you have a very good possibility of having a better life. If anything, if we did have a malaria outbreak in the United States, you're actually partially protected, and it actually helps you survive as opposed to people that have normal blood cells. So, hope this helps someone um, scientifically. And anyway, everybody have a great day.